Good morning, everybody. So today we're going to be working on my Creality Ender 3 Pro printer. We're going to be upgrading this direct drive extruder, which I've been having some problems with, to that new Sprite Pro extruder. Full disclosure, I've never done this before. I didn't really do any research on the procedure, so we're going to be figuring this out together. Don't know if there's a firmware upgrade required or any tuning, so we'll get into it and we'll figure it out together. Main reason, well, there's two reasons why I'm doing this procedure. This cooling fan is failing. You don't hear it right now, but the other day when I started, I think it was crazy loud. I think that is causing some cooling issues because it's not spinning as fast as it normally does. I don't know, you probably can't tell from the sound, but it sounds a little wonky. Also, I've been having some problems with just like a whole bunch of spaghetti. First layer issues. I've already leveled the bed. I've already, as you can see, I have a BL touch here for bed leveling, so that's not the issue. I think there's something going on with the extruder. I'm just not sure what it is, but honestly, this was a $30 kit. Wasn't really that expensive to begin with. And this fan is like by itself, before shipping, is like 15 bucks. So didn't really seem cost effective to put any parts into this extruder. So rather I decided to invest in the Sprite Pro extruder, which you can see in here. That comes with a ribbon cable. This short little cable, I believe this is for hooking the BL Touch to the extruder. New carriage here, some hardware, and the extruder itself right here. Don't drop it, don't drop it. There we go. So again, I didn't really do any research on this. People seem to like this extruder. Seems to be the go-to anytime anybody needs an extruder. So I don't really have a good understanding of what the advantages are. So if you're looking for that, you're looking at the wrong video. That aside, let's install it and see if it makes a difference. So I'm going to bring the printer out here just because it's a little cramped to work in there and it should be a lot easier to do it here. We'll start by removing filament spool, which is, looks like it's almost done anyway. And it's very brittle. I might just toss this stuff. So we got the power cable back here. I got a webcam here, so we'll trace. I really should clean up some of these cables. It's kind of a mess. That's the power for the Octopi. So just to describe this setup for in case anybody has been watching any of my 3D printing videos, I got a Raspberry Pi in there that runs Octoprint. That's like a web-based user interface that manages the whole printer. Connects to the actual printer board down here using this USB cable. As far as upgrades, you can see I have the direct drive extruder. I have the Creality 4.2.7 motherboard. Got some miscellaneous stuff here like the belt tension adjusters. I got a dual Z-axis screw back here. Yeah, that might be about it. Probably forgetting something. Definitely love the BL Touch though. I would not be 3D printing without that. It was a life changer. I also have that, like this ball bearing printer spool holder thingy. This thing here. Absolute trash. Don't waste your money on it. Doesn't do a thing. I'm going to start by cutting some of these zip ties off. These will all need to be redone. I guess you probably don't actually have to do this since you're replacing the whole extruder, but Okay, I think that might do it. Now we'll need to access the motherboard. Which is right under this cover here. There's another screw back there too. Don't pay any attention to me. I forgot that there were screws in the bottom that held this thing in. There's 3 of them. I already took one of them out. I put that one on top back in. Been a little while since I've been in here. Wait, what? What's holding us in? And I forget how to get in here now. I took those 3 out. Does this top screw have to come off? So this separates here. And it wraps around. Maybe they do have to come out after all. Boy, I can't remember. Yeah, I had it right the first time. It was the 3 screws in the bottom and that one that I took out and then put back and then took out again. So now we have access to our motherboard. You can see this is the upgraded one. So now we need to undo this electrical tape that I threw on here just as to prevent abrasion. Would have been nice to have seen a grommet through this cutout in the extrusion, but that's what you get for 200 bucks, I suppose. There we go. And all the wires separated. We're going to have to spend some time, or I'm going to have to spend some time undoing these connectors. You can see there's a bit of hot glue on them too to prevent them from coming apart. That's pretty important. That for some reason these connectors are not the greatest quality and they've been known to wiggle loose. So I'll work on that off camera and pick off some of that hot glue so we can start pulling these connectors off. All right, so when I did some of the upgrading the last time, I guess that's when I put this motherboard in. I put hot glue on X, Y, Z, or Z, and the extruder up here. I was able to pop the hot glue off of this connector. I also put hot glue on the K-fan connector right here. That put up a little bit more of a fight, but still not the end of the world. So at this point, it's really just a matter of unplugging the old and plugging in the new. So we have a cable here that's labeled E for extruder. I don't know if you guys can see that, but right there. So we'll just undo the extruder connector up here. Carefully. There we go. We will plug in the new. Like so. Let's see what this one. This is K-fan. And I think that goes in here. This K stand for cooling. Next, I'm working on the hot end thermistor, which is down there. And let's see. That's this TH cable up here. Just doing one at a time here in case you couldn't tell. Okay, got that in there. Let's see, now we got to do what's left. Got the CR Touch, which is this. This is for the bed leveling. Let's get this out of the way for the moment. Right there. Got that out of the way. Accidentally yanked the display out too. We'll get back to that. Now what? We got this unlabeled one. Yeah, there's a couple of unlabeled things on the harness in the instructions. The instructions do kind of give you a hint of where things go. So this diagram here is for the 4.2.2 board, but I think the 4.2.7 is the same. That's what I have. Then you have the diagram for the cable itself here. So I'm going to spend some time and just kind of run through this. Again, I'm going to go through the procedure of unscrewing something from the old harness and screwing something right back in its place on the new, just to prevent any mistakes. So now the direct drive extruder, I don't see, are there any indications on any of these leads, which one's positive, which one's negative? Let's see, hot and, yeah, so no indication here. Wire colors are the same. Let's take a quicker look, closer look. Yeah, it just says hot end. It doesn't say plus, minus, whatever. So I believe the polarity on this matters. It does say heating tube, and heating tube, pay attention to plus, minus. So we will do that. So now heat plus looks like it is the connector on the left. Which is that one there. And then heat minus is the one just to the right of that. Tell you, I'm really not a fan of this ribbon cable. I like the other one better. These wires are really skinny. Tighten these down good and snug. Don't want these to be loose. Check all your connections. Make sure they're all tight. So let's see. So we have an unlabeled 3-pin, which is what I see in the instructions. We should have an unlabeled 2-pin. Which is right here. So I think we did everything correctly. While you're here, it's not a bad idea to check that your input power connector is still tight. We can bundle this up good and pretty and shove it back in here. Something like that. And like before, we'll wrap this with just a little bit of electrical tape just as an abrasion resistance measure. Don't want any of these shorting out on the frame. So just offer a little bit more protection. It'll get bundled nicely in there, just like so. I do need to put the display back in since that fell out. And then we can put this cover back on in theory. But I think I'll leave the cover off for now just until everything is demonstrated to be working properly. Although, actually, you know what? No, I take it back. It's just such a pain in the neck to take this cover off. I'll put a couple of screws in it. Okay, now it's time to remove the old extruder. There's a 3mm bolt on the back here that holds this roller on. I think you just have to loosen that one up. Is there a nut on the other side that's spinning? No. Maybe I need to loosen these guys up too. No. Yeah, I do this so infrequently I can never remember the exact procedure. We'll take the bottom roller off. Not going to hurt anything at this point. Yeah, I put this thing on here. I should know how to take it off, huh? Let's see if the belt is holding it in place. Back some tension off the belt. No, it shouldn't be the belt holding it. Oh, there may be a nut on the back side here. Get the BL touch out of the way for now. It's going to have to come off anyway. There's another one down here. I'll tell you, this direct drive extruder was a workhorse. Got a lot of prints done with this thing. I didn't have to deal with those stupid tubes. Never was a fan. Okay, there's our BL touch. We'll set this aside. Yeah, as I thought, there is a nut down here. Get a wrench to hold that. Looks like that's going to be an 8mm. There we go. We'll slide the belt off. 1, 2. Okay, our extruder is now free. We'll set that aside. We'll unplug the extruder wiring harness there. And I guess, yeah, probably don't need that part of the harness, factory harness anymore. So let's get the new extruder hooked up. Similar procedure here, I assume. Let's back off on this adjusting nut here. We'll stick an 8mm on the back. So in case you couldn't see it before, I got an 8mm on the back there. And we'll just turn this Allen key here to loosen up that bottom roller. Slide the belt in the slot. Slide the other end of the belt in the other end of the slot. This thing needs to come off more. Nope, might need to come off more. There we go. Some tension back on the belt, make sure it moves okay. It does. Let's tighten that bottom roller. Seems reasonably tight. One point of interest, as I was tightening this, I noticed that it seemed to be tilted back this way a bit. I think that, I'm not sure if it's something I did or if it's something that was assembled wrong at the factory, but there's a little cam underneath this screw, and that cam was sitting on this metal bracket. It wasn't inside the clearance hole drilled for it. That cam allows you to adjust how much tension from the wheel is on this, like it just makes it tighter. So make sure that that is lining up correctly. You'll know because this stop over here on the right side, or left side, it was just barely touching that limit switch there. So if that's happening, you may need to make an adjustment. Or by adjustment, I mean take this thing apart and fix it. So now we can take the new extruder and bolt it onto that bracket. And they give you, let's see, a spare nozzle. Yeah, here's a bag of screws. Let's see what size are these going to be. Yeah, these are those really tiny ones. So let's get our extruder. There we go. And of course, it's the wrong size Allen key. Never fails. So I got that one in by hand. Let me go grab the right size Allen key. So the right size is 2.5mm. All right. And one of the wonderful parts about this is it looks like the adjustment screw for the preload on these rollers on this carriage is covered entirely by the extruder. So make sure you get that tight before you do anything. This feels a little loose. I think I'm going to adjust that a little bit more. Realized it might be better to plug in the cable for the CR Touch while everything is off the printer. So I'm going to go ahead and plug in the cable that comes with it. There we go, just like that. Then we don't have to fish it around in there between this in this tight cramped space. Yeah, that's much better. Let's put these screws back in. It's a shame you can't adjust this without removing the extruder. That's kind of annoying. All right, got all that buttoned down. Now I think it's time to install the BL Touch, and looking at this now, I probably should have done this in the reverse order. It's gonna be a little more difficult to do this upside down, but probably still doable. I'm gonna unscrew the BL Touch from the existing bracket. I'm gonna screw it into the bracket that comes with the new one. I'm assuming this is designed for the CR Touch, which is Creality's version of the BL Touch. From what I understand, it's just a clone. I think I bought this BL Touch before the CR Touch was even a thing. Let's plug in our harness. Yeah, I just can't see anymore. It is the same connector, right? Yeah, sure looks like it. It just does not want to fit. There, I think that did it. It's the expression of a don't fit, force it. So about like that, I think, right? Alrighty, now we got our ribbon cable. And back here, it gets plugged into the extruder here. Looks like they want this inside this little bracket here. Cable management. Always like a good cable management. Cool. I think that's it. Ready to power it on and see if it lets out the magic smoke. Let me get you a couple different angles here. It's another view. We have our cable coming in here. You can see that this bracket here is nice and straight. It contacts this limit switch pretty evenly. Filament will go straight into there. Let's power it up and see what happens though. Okay, I just gave power to the Raspberry Pi and everything lit up. Let me turn on the actual power supply to the printer now. Cool. Media and knit fill, that's lovely. Okay. Let's do an auto home. So far, so good. You can see right off the bat the BL touch is not centered. It's kind of over here. We probably need to adjust some offsets. Okay, that's a good sign. What's next? Probably need to do some firmware offsets to get all this set up. I think someone mentioned online something about e-stops too. Let me dig into that. Let me dig into that a little bit and I'll get back to you. Well, will you look at that? The manual tells you what to do. Right here, 424.9. So let's go into the menu and we'll adjust it. Hopefully you guys can see this. Go into configuration, advanced, steps per millimeter. Key steps, we do 424.9. Might be here a while. Okay, there we go, 424.9. Is there anything else we need to do? Might be it. Probably just need to do a bed level procedure and set the offsets here. Let's do a configuration and store. There we go. Now when it comes to setting the X and Y offsets, what I like to do is I like to use a piece of paper. What I'll do is I'll take a blank sheet of paper, stick it on the bottom, and poke a hole through the paper with the BL Touch and the nozzle. And that'll give me a hole in one location and a hole on the other. So nozzle and probe. Then you simply take a caliper and measure the distance in the X direction and the Y direction, and you can use those as your XY offsets. So I've already measured those, so our probe offset is 33.3 millimeters in the X direction and 37.53 in the Y, measured with a set of these Mitutoyos. I mean, these are far more accurate than my punching method is, but it'll be close enough, and it's a lot easier than getting a caliper under here and measuring, and so, yeah. Now, as far as the Z offset, there is a wizard for that. So let's go back here. Let's home the thing. Take a minute to go through its homing wizard. And from there, if you have it burned into your firmware, I'm trying to remember how do we, I think we do motion and then Z probe wizard right here. Not all firmware has this built in, so that needs to be compiled into the firmware, turned on in the firmware. There's an option for it in the Marlin config. I will share all my configuration files for this build when I'm done, so don't worry. Keep in mind that my printer is probably not the same as yours, so you may need to make some tweaking, but at least the config file should give you a starting point. So we're going to take that same piece of paper, slide it under here. Going to move the Z axis in 1 millimeter increments until the paper starts to catch. So far, paper is completely free. Okay, locked in. Now we'll go and move in 1/10 of a millimeter increments. So locked at 1.8, unlocked at 1.7. Now I'll move in 1/4 millimeter increments. So at minus 1.775, that's when we just start to feel some resistance. So let's write down this value, minus 1.775. Done. And then what we'll do, where's the Z offset setting? There's one in here. Main, so configuration. Interesting. It seems like it may have already updated it. So our Z offset is minus 4.87. Cool. So what I'll do is I'll burn that into the firmware. This way I only have to configure this once. You can set a default value in the firmware. Okay, everything was going really swimmingly, and I was getting ready to heat up the hot end to do some bed leveling and whatnot, and I was getting these error messages on the screen about the extruder wasn't heating up. I noticed it was staying at a constant temperature, and I took apart all the wiring that I did, figuring I did something wrong, but I don't think so. If you look down in here really carefully, I don't know if you guys can see this, but there's a red plug in here, and it's just dangling there. It's not plugged into anything. It's a heavy gauge wire, so I'm guessing it's supposed to be plugged into the extruder. I don't know if that's a manufacturing issue, or I didn't see anything in the instructions about plugging in the heating element to the extruder, but that is clearly not plugged into anything, so we got to dive into this a little bit more. Sadly, I think that means we got to take all this stuff apart and recalibrate everything, which we already did. It's unfortunate, but I have to remove this cooling fan to get to that plug, wherever it's supposed to go. And I also have to remove the BL touch, and that'll mess up our probe offsets. So we'll have to go through that procedure all over again. Good times. Come on, Creality. Very disappointed in your quality control here. This extruder was not cheap, you know, it was $100. You know, if it was a cheapo $30 one, I wouldn't be complaining as much, but this thing actually was a little more than $100. Hoping I don't have to take off the extruder head again, but if we have to, we have to. Okay, BL touches off. Now I'm just going to remove the final screw that holds in this cooling fan on this side here. They weren't very tight. Yep, and here's our little wiring harness just kind of flopping in the breeze here. I don't think it's supposed to be like that. Oh, I see where it's supposed to go. Believe that somewhere is right here. Alrighty then. So check your parts before you install this thing. Wow. Just wow. I could say something, but I won't. I'll leave it at, I'm disappointed. All right, let me get this put back together. Pretty strange, I now notice this little pigtail right here that I honestly didn't notice before. I'm wondering if this is a me problem, but that label pretty clearly states that the heater has to be plugged in. So I don't know if it was just tucked under there for assembly, and I don't know. I'll be honest with you, maybe I just overlooked that label, but yeah, at least now it's heating up. Everything's doing what it's supposed to do now. So I got the bed all trimmed in. There's a procedure in the firmware you can use to trim the bed to make sure the corners are within tolerance of each other, and you just adjust these, the leveling screws as you would normally. And once you do that, level the bed, and then we can hopefully do a test print. Another little gotcha I noticed while I was adjusting things here is whenever the extruder got all the way to the right side, I heard this horrible grinding noise, and I traced it down to the screw on the bottom, on the back, on that wheel that we loosened to get the carriage onto this rail here. It actually contacts this gusseted piece down below. So it'd be nice if they called that out in the instructions. I suppose you might be able to get a shorter screw. I don't know. You won't be able to fit a nylock in there, I don't think. So one thing you could do is, like I said, get a shorter screw, or you could adjust the X maximum position in the firmware, so it sets up an artificial travel stop in advance of that. So I think that's what I'm going to do, since it's getting late and I don't really feel like ordering more hardware from Amazon right now. So let me get the firmware flash with that update, and we'll give it a shot finally, hopefully. Alrighty, it's the next morning. I got the firmware all updated with a setting to limit the X-axis travel so that nut doesn't contact that bracket. Now printer's on. Let's go. Let me go queue up a print of the benchy, and we'll see if this thing works. Wait a second. Not one of you warned me to load the filament? Jeez, be a pretty boring print until we load the filament. All right, so let's go to temperature, preheat PLA. Preheat PLA, and then we'll take our spool. Well, I won't go through this. I'm sure you guys know how to load filament. I will say it's actually a much more convenient procedure because you just stick the filament in that hole and turn this gear. That puts the filament in. It's not that direct drive extruder. You had to line up the filament going in with that little brass wheel that drove it, try to get it down that tube, and it was a nightmare. It took a while. You need to be able to see the back of the extruder, but you can't because it's in this enclosure. So this is much easier to load for sure. The extruder's all warm. I just turned this little hand wheel or little gear that direction a few times, and now I got filament coming out the end. So now we'll queue up the print. All right, print is queued up. The bed is heating. And while the bed's heating, anytime you make any drastic modifications to your printer like this and you start a print, you want to keep your hand on that power button just in case something goes awry, or you have some kind of crash or whatever. So just to be on the safe side, I always tend to supervise the first few prints, or at least when they get started, depending upon how confident I am in the repair. I think we're going to be pretty good with this one, though, I hope. So the bed is at 47, 48. The extruder is already at 185, so that should trigger a bed leveling procedure any moment. There we go. So now it's doing the bed leveling. Probably should bring that probe in a little bit. It's pretty close to the edge there. We'll do that some other time. I can't remember if I mentioned it yesterday when we were recording, but I did also follow a bed tramming procedure, which is another thing that's built into the firmware. You have to compile that into Marlin. It doesn't come from, it doesn't come turned on by default in most cases. So what that'll do is that'll bring the probe to the four corners of the bed, and it'll tell you to turn these little knobs at each corner to get the bed corners at least in a relatively level position relative to the probe. So I did that off camera. Pretty straightforward though. And notice that we're not crashing into this bracket over here too, because we adjusted our X maximum position. Now we're homing. The print should begin any moment now. Oh, we got to heat the bed up to 60, that's right. I was doing some research online last night, reading in bed, and it turns out the Ender 3 has actually kind of fallen out of favor. I haven't really been keeping that well in touch with the 3D printing world. This is a tool for me. I'm not obsessed with this. I use this for, for work, to make parts in the garage and whatnot. So I don't always follow the latest trends in the industry. But this machine's fallen out of favor. You can get better machines for the same or less money. Folks seem to like the Bamboo Labs machines now, and also the Prusa MK4 S has come out, which is supposedly crazy fast. I think it could print a Benchy in like 8 minutes. This thing takes in like an hour and 45 minutes. So this might be one of the last videos you see about the Ender. I may have to do an upgrade at some point, because I bought this in 2019. It's 2024. And again, I haven't really been following the industry, so clearly things have changed, as one might expect. So we are printing. Got a little strip right there. A little goob of filament there. So far I don't see anything concerning. Seems like the first layer is adhering, as one might expect. Get you guys in a little bit closer. Cool, we'll let this run for a little while. We may still have to adjust our E-steps. The manual did say, in my research online, confirmed that value of 424.9 that we threw into the firmware and actually burned into the firmware after, off camera, that is just an initial value. So they do recommend tweaking that and adjusting it based upon your specific setup if you have under or over extrusion problems. I don't know if we're going to have those problems, but let's wait until this finishes and we'll take a look. And we had a first layer failure. So yeah, I think we probably need to adjust our E-steps. We probably have an under extrusion situation going on. So I'm going to abort this print. And that's what we're left with. Yeah. Before we go changing settings, let me just do one last thing. Let me clean the bed. There might be some kind of oil residue or whatnot, because I was touching this thing. It was all over the workbench, being flipped upside down, backwards, and it could have gotten dirty. So let me clean the bed with some rubbing alcohol, and then we'll try again, just to be on the safe side. If it still have a problem, then we'll look at changing those E-steps. Changed my mind. I'm using acetone, only because it was a little bit easier to access. All right, so that's what came off of it. Okay, we're back to printing. Let's see if this is any better or any different. Probably also would not hurt to replace this build plate here. That thing is super, super old. And as you can tell by some of the marks on it, we had some some issues at one point with Z clearance. That was before I got the BL Touch, though. All right, let this run for a little while. A couple minutes in, things seem to be going a little bit better. I don't see any adhesion issues anymore, so we'll let this continue to print for a while. Okay, our benchy is done. Doesn't look too bad. Not bad for a raggedy old printer, right? All right, now let's take some time and verify that our E-step measurement is correct. What I'm going to do is I'm going to take a Sharpie. I'm going to mark a black line on the filament 100 millimeters up from the extruder here, and then again at 120. It's going to be hard to see on the camera, but you'll have to take my word for it. So I'll get the caliper dialed into 100 millimeters, as close as possible. Close enough. Let's move our Z-axis down a bit. Oops, I did auto home by mistake. Oops. Let's try that again. That's right about. Yeah, you can't really see that at all. Jeez. Anyway, so you got to do a mark at 100 millimeters and do another one at 120, just to account for any potential over extrusion. Might be a little bit easier to see, but I switched to a silver Sharpie. Got a mark at 100 and then 120. So now we're going to go into the control panel, go into motion. Or was it motion? Or was it? No, it wasn't motion. Yeah, it was motion, move axis, move extruder. So now we'll move. Looks like we can only do it in 10 millimeter steps. So let's try this. Let's do 10 millimeters. That's one. Oh wait, we can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 100 millimeters. She's still running. You can see the marks approaching the extruder. You can see this gear turning here. So if this 100 millimeter mark stops right at the nozzle, we're dead on in terms of extruding. So it's right at the nozzle now, and it just stopped. Yeah, so I think we are perfectly configured here. We don't need to make any adjustments. Our E-steps are correct at the default of 424.9, I think it was. So, slightly better image. 100 millimeters, 120. So again, no adjustments needed. Now, if you did have to make adjustments, you can figure out how much was over-extruded or under-extruded by measuring with your caliper. And there are online calculators you can go into. If you just do a Google search for E-step calculator, what they'll do is they'll allow you to enter in the amount that you did extrude, whether it's more or less than 100 millimeters, and they'll give you a new E-step value to plug into your firmware. Whenever I make changes to those sorts of things, I typically flash them into the firmware, but this way, if I ever upgrade, they're retained, but you can always just save them into the EEPROM if you don't upgrade your firmware as often as I do. Anyway, hopefully you found this video helpful. There were quite a few gotchas that we ran into installing this thing on this printer. It was not plug and play. It's obviously designed to fit a bunch of different models, and it sort of fits the Ender 3 Pro, but you do have to make some adjustments. So if you found this video helpful, please subscribe. Stay safe. Thanks for watching, everybody. Take care. And as a reminder, I will leave links to the configuration files that I use to compile this firmware, and I'll try to leave a firmware binary itself in case someone has this exact same configuration they'd like to use it. Thanks again. Take care. Bye.